Hello. Hi. This is an assembly video for the next project coming in June. It's let me just load up the stream. It's a collaborative project between we talked about it in the previous video, between Boldport and Rare Waves in America, in Texas, and it's called Lite2Sound, and that is basically a device that turns light around us that is in audible range into sound. Bad explanation. I could probably show you a quick demonstration of what it's like. Got a pre-built one here. Let me first show in the scope. This is the kit, that's how it comes, and this is what it makes. And inside is the project. The unique interesting thing about it this time is that it's going to be, the enclosure that's shipped in is also going to be the enclosure for the electronics. And another interesting thing about it is it's a surface mount project, which is a lot different to what we normally do. Well, we've done a few surface mount projects. The last one I think was Bingo, and yeah, so it looks like this. And I can give you a quick demonstration of what it does. We can use the studio lights, because the studio lights are all pulse width controlled, or like various different dimming techniques, and they're all LEDs, so they should make some nice sounds. Plug it in. Nice sounds. They're not that nice. They're just like gnarly, distorted sounds. The enclosure is shielding as well, which helps with the audio. See if I point it round. That's the monitor. If I go here. What else can we find? I think that's the lights. They're the video lights. There are controls inside. One is for power. One is for gain. It's going to blow your head off. Or not. And there's a volume knob too. Anyway, that was a brief introduction. I'll go in more to detail later. One interesting thing about it is it comes with two different diode sensors. There's this transparent one, and you'll also get a black one, which is an infrared filter. It's up to you which one you want to use. The more diverse, like the one that can pick up most dynamic range of light, would be this one. But this one could be interesting if you're just interested in infrared. I don't know. Anyway, let's get on to building. Let's look at the kit. So, here's the kit. You'll need, to build this kit, you're going to need cutters, sort of. You'll need them for wiring up the audio jack, and for doing some of the 3-hole components. There's not many, but there are some because they're more mechanical. And tweezers. This is needed for the little chips for surface mounting. And in this case, you're going to need 3 little wires. Doesn't really matter the colour. Ideally, they should be quite flexible because they have to squeeze inside a tin. You could go to your local electronics store and buy some, or you could salvage them from something. It's not too fussy what you need. They just need to be made out of metal and insulated, and of course solder, and maybe desoldering stuff. It's not super essential unless you made a mistake, which you could do, but that's okay. So here's the kit. Let me just move this all aside. In the kit you get a front sticker. This is beautiful as well as functional. It goes on the front and it acts as a sort of very crude pinhole sort of thing. It lets you make it more directional rather than picking up light from all sides. It focuses more down the front. You don't need it, you could just have that and the light is shining through there. It would mean you get more light coming in from the sides. You get the components, PCB, and a little bonus sticker. This doesn't do much, just for fun. Chuck that aside. Don't get rid of the tin, it's part of it. But let's just put it over there. So, to know where all the components go, there's a fairly detailed instructions. It's printed in black and white here, but it's actually colour. It tells you all the components and what their reference designators are. And it also the switches and stuff. And then there's a second page that tells you how to mount the jack socket, which is not on the PCB. It's an off-board connector, and how to set up the tin and put in the jack socket and the battery. Okay. Now, it's a good idea. Not essential, but in this case we're using ESD protection just to make sure nothing like that could go wrong. It's quite humid today, and I've got a fan that helps. We've kind of like modified this fan to suck out any fumes from the solder. If you just tap it, you should probably use something a bit more heavy than this, but we need to find a nice silent fan. So, the components. Careful not to cut through any of them. This is quite a large amount of components in this kit. It was because it's a sort of analog op-amp based project. It was quite hard to keep the BOM down. Eric did a pretty good job at sorting that out, but yeah, as you can see, I think, what is it? There's, I can't remember, 15 items. I can't remember. It's quite big compared to others. So you get a jack. You get some battery contacts. There's these little chips and integrated circuits. There's a pot, and then there's two diodes. With this one we're going to be building the black one, so I'll put this transparent one aside. I'm only building the black one because we've already got a transparent one. I'd recommend doing the transparent one first and then experimenting with the black one. And PCB and some feet. This is for the tin. Stops the contacts being on the tin, but we'll get to that later. Now, because there are some bigger components and some smaller components, it's better to do the small components first, because the big ones can get in the way when you're manoeuvring with tweezers. You know, if you're like picking up, you need to get in at all angles. This is explained in the instructions, and in fact the parts list is done in the order of size. So you start with the small chips and then you kind of graduate up to the bigger parts, and then the big through-hole things. Let's look at the board. It's quite unusual that it's not all laid out in a big grid. it's sort of done round a central point. Like, don't get too intimidated by this. It's just it's decorative, but it doesn't actually make it a lot different. And on the back, there's not much. It's just images and the base with the through-hole components. Now, let's check my soldering irons all fine. Let's start with the first component, which is a 220 picofarad ceramic capacitor. Ceramic capacitors aren't labelled, they don't have any markings on them, but luckily in this kit each capacitor looks totally different. So if I show you the two capacitors, where is it? Here it is. The one that we want is this one, this white packaged one. It's also got a light, you can't really see it in the camera, maybe if I do it in the microscope. Where are we? You see they're sort of white compared to this, which are more like tan coloured. So these ones are the 220 picofarad ones, and these ones are 100 nanofarad ones. You can also tell because these are in 2 and these are in 3. This is the hardest thing to recognise, but don't worry. So we'll start with the these ones. Now to solder, it's best. Let's first find where the pad is. So we need these 220 picofarad ones, the whitish ones, to go to C5 and C6. If you look on the board, there's C6. Maybe I'll expand this a little bit. Okay. There's C6. Now to solder it, what we should do, take that off. To do hand soldering of surface mount, you just dab a little bit of solder on one pad and leave the other one undone. And then you bring over the component and you put it on and melt it on. That way it will be flat on the board, and then you can solder the other side. If you did them both with solder and you tried to melt it on, it'd be very difficult because you'd only be melting one side at a time. You end up with it wonky. So let me show you that. I can probably try and do it under the microscope. I'm using quite a fine solder and quite a fine tip, but it's not essential. You can use, I can demonstrate to you actually that you can use quite a chunky iron. What you get, I mean, check out this tip. Huge. And use, so if you just put a little dab it on like that. See that? See the side of that? It's fine. Now, just open the. Be really careful when you're opening these tapes. I'll do this on the microscope too. You can peel it off with the tweezers. Be super careful not to ping them anywhere. Just flip them over. There they are. Anyway, let's get the board back. You just see, very carefully pick up the component, put it roughly in place, and then melt. There we go. I mean, that's not even in the center, but it'd be valid. But let me put it in the center. Okay. Then just turn it round. So your iron's on the right side. Put your iron in. Melt it. Ah, wasn't on the other side, wasn't tacked down properly. You'll know it's right because you'll get a sort of fillet that goes between the pad and the board, the component in the board. I can try and show you here. Not sure if this will come out very well. No. See? Okay, what's the next one? Of the same component we want C5, which is, where is it? I'm looking at the page. C5 is, oh, it's hard to see because it's inverted. Is that right there? Be very careful when you lay components out on the worktop. It's so easy to just like brush them off. Sticks in the air, you can hold it down. Next, we're going to move on to the brown ones I was talking about. That's C2, C10, C7. I'm sure you're enjoying this. Slow peeling. So what was it? C2. That is here. It's always good to turn it so you're soldering on the side of your soldering iron. Key to surface mount soldering by hand is really just being very careful. It's mainly just not losing things and knocking them off the table. After you've done a few resistors, it'll get easier. Capacitors. So what's the next one? C7, which is it's another one. See, it's there. Bit lumpy. There is another option. We've uploaded to OshPark a template for a stencil that you can order from them if you want to do reflow instead. It's not really, there's not a lot of components on this board, so it's not really worth it. But if you wanted to try out using reflow techniques instead, that'd be fine. C10. So I'm going to rotate it. Also note in these, we're sort of testing out the instructions too, so we might change things if it proves to be better to do it a different way. Run out. Okay. Now we're past the little capacitors. We're on to the little resistors. They're here. You can tell what they are because they're black with white text on them. The white text shows their values. And you might notice that the resistors you get are the resistors on the bottom are all different sizes, like there's one of that, two of that, three of that, two of that. But actually you get 3 of each. That was just because resistors are so cheap. We thought you might as well have some spares just in case you drop them or something like that. Or you could use them to experiment or something. But the first resistor here is the 10 ohm resistor, which is R7. Show you R7 on the board. R6. Here it is. There's R7. And it's 10 ohms. So maybe a bit cryptically, but if you look, it's actually got the number of what it should say on it, and it says 10RO. And we can find that. Here it is. Can you read that? Brighter. Just about. Oh, it's upside down. One ORO. We only need one of those, but you get 3. Be really careful after you finish with it. Make sure you put these somewhere, otherwise you might accidentally end up putting them in the wrong place. So back to R7, rotate it round so the soldering iron can reach that side. And just swap back to the other tip just because it's easier. Thing about tools, you can make things easier but you can make do with what you've got if needed. Okay. Lost the resistor. Struggling. If anyone watching's got any questions, don't be afraid to ask. They might distract me and I might mess up. Joking. Next one is 220 ohms. That's R3 and R4. These are on the audio output. It's for limiting the current through headphones, I think. I might get corrected. We'll do them together, just 'cause they're next to each other. That is 2200 here. Get them out. If you lose them, don't worry too much. I'm sure we can help you out with some new ones. Or it's pretty easy to find these in small quantities at your local supplier or on eBay. But with the resistors especially, you should have some spares. The main thing about surface mount soldering is not that it's more difficult to solder. It is, for some packages it is, but resistors and stuff, it's pretty, at this size, there's not a lot of difference. The main trickiness is not dropping stuff and getting it in place in the first place. Once you're in, it should be quite straightforward. Just practice. If you're not very confident, you could try finding there's plenty of surface mounting kits, you know, learning kits out there. Okay, next one. 20k. And that's R1, R2 and R9. That would be 2002. Here. Ping. Be careful, these you need all three. These are for R1 and R2. It's a voltage divider. This provides a half rail voltage. It's for the op amp that's on the board. See, this is a good trick. Let me show you. See that they're upside down? A quick way to get them the right way up is just to put your finger on them and let them drop. Keep doing it until it's the right way up. Another trick is people do is they put it on a bit of paper and they hit the table. They flip, but that kind of risks launching them somewhere. Back to this. Quite tricky. I know people always complain about this. It's quite tricky doing it on a microscope, so bear with me. Yay. That's R1 and R2. The next one is R9, which is here. See, it doesn't matter too much how central you are on the pad, as long as there's a bit of copper showing, should be alright. It's hard to show, but what you want is, just like you would with 3-hole soldering, just a fillet that goes between the component and the pad. That is all the resist. Oh no, wait, too keen. There's one more resistor. The 2 mega ohm resistor, the biggest one. There's 2 of those. They are. Can you see that? Yep. 2004. Oh, that's funny. They're upside down. We only need 2 of these. Do the trick. And this is R5 and R6 to these 2. can't tell you too much. There might be certain methods you can do for hand soldering. There are definitely a lot of better videos out there showing you how to do, probably with better cameras showing you how it works. But you should be getting the gist of soldering this. Okay, that's the end of the resistors. The end of the resistors. Next we'll do the diode, which looks very similar. But it's got tiny, you can see it's got two little tiny feet. That is here. Tiny. Under the camera. This one is probably the trickiest for seeing the markings, because for some reason the manufacturer decided to do the thinnest hairline marker you ever could imagine, in the faintest grey. I think it's laser etched. No. Here it is. This is probably the worst component, but don't worry. Do the same technique. So that's it. Let me see if you can see that. Let's get a good angle. Make it bigger. Oh, you can just about see it. It's easier by eye than it is in camera. There's a little line here. There you go. Tiny stripe. That means it's the cathode. If you look on the board, I wonder if you can get both in the same shot. That is DT there. So this triangle means that's the anode and that's the cathode. That stripe has to be the non-stripe has to be the. So we keep it all in shot. I'm doing this at a funny angle for me. You should be able to see it though. Okay. See the stripe is there. Another way of knowing is the stripe should be here towards this side of the board. Okay. Done. Oh no. Need to get the microscope back. Okay. See, I've said do these cans next, but I think it's better that we do these. These are the ICs. This is an op amp and this is an amp. This drives the headphones or speakers, and this is what converts the small current from the photodiode up to all levels. It also filters out DC and stuff like that. So we're going to do the chips next. start with IC1. And it's this component here. It's the TLO02. Again, with surface mount, they like to do the tiniest laser markings. What does that one say? I can't tell. What does the other one say? That's the amp. The amp should be easier to read. It says LM3, what is it, 386? Yeah, 386. Like an old Intel chip. And this, once you take the plastic off, it should say TLO72. That's IC1. Sorry, that was a bit confusing. I'll show you. That more readable. If I change the brightness. Yeah, I think you can just about make it out there. It says TLO72 or 072. Now when you solder a chip, an IC, what you need to do is very carefully solder one pin. It's exactly the same applies. You only want to do one pin so it's flat when you solder it down, because you can't possibly solder all 8 pins at once unless you're using hot air or some kind of reflow. When you're doing it by hand, you need to do one pin, push it in. So there's the chip. I prefer doing it with hand. Do it with tweezers too. Sorry you can't see. Try not to burn yourself. See? There's one. It's a little bit wonky. You can also do it like this, holding the chip. So before you go any further, you need to make sure that all the pins are lined up. Anything wonky can make it a bit difficult. You need to solder the pins. Same applies, make sure there's a sort of fillet between the chip pin and the pad. Okay. Now we'll do the other chip. Here, IC2. That's the one we recognised before. Oh dear, I've realised I haven't told you something. And I've done it. I put it in upside down. Oops. For speed. You can remove an IC by melting all the pins on one side. Then lifting it. This is a lesson. Check. Always check it's the right way around. Whew. That would be reusable, but I could probably reuse it. It's fine. But I don't want to risk, just in case I've damaged it. Use some wick to take everything off. What a disaster. The good thing about this is you can see what happens, what you can do if you've done something wrong. I'll just clean up the other one. Where's it gone? It looks okay. None of the pads are joint or anything like that. So, I'm going to put it in the right way round. What I failed to mention and failed to do is that if you look really closely, turn the brightness back up, these ICs have a little marking here, there's a dot. That means pin 1, that means that is pin 1. And so when you're soldering on the board, I've left a little marker here, meaning this is pin 1. So this is meant to be this way round, like that. I'm here to make these mistakes so you don't have to. That way round. Make sure my chip's the right way round. For speed, it's just going to have to go in like that. This wick is very useful. It lets you pick up any solder on a pad to get it back to flat again. Okay. See, there's no joints been covered in flux, but it's fine. Next we'll go to this one. Bit solder on one pad. Now this one has the same, has a little dot. But there are actually, in some kits, because the manufacturer sent a variety, well, the distributor, they might actually look like this. See, there's no dots on it at all. But very subtly, it has a sloped side, this side. So you'll either get one of these, or you get one with a little dot. It's explained in the instructions. for the amplifier chip, you can see there's two different types. It tells you what the orientation of it is. Take loads of care, unlike me, to make sure you've got it the right way around before you start soldering down. Let's hope I didn't heat that chip up too much. Should be okay. There they are. Now, next, we're going to move on to these can capacitors. We've left them off because they look like this. Quite big. They're electrolytic capacitors, like the ones you get in through-hole, the black ones. But in surface mount they decided to keep them silver. Just print on the top what their values are. They usually come with a funny bit at the bottom, plastic foot. I guess that's for helping with surface mount soldering. We put them under the microscope. We're going to use the small ones first. They look like this. They're 10 microfarads. If you look on the 10 microfarads, that's C1, C4 and C3. On the board they look quite similar to the other capacitors, except for you'll notice these are polarised. So because it's easier to mark, the positive sides are marked. So the positive side of C4 is there and the positive side of C1 is there. If you look on the can, you see there's a dark semicircle on it. That means the negative side. So if I solder that, just you see here it's tricky, so one will trap the other one in. So do you see one? I'll show you. When they're big like this, it's usually easier to do it by hand. I know it looks awkward. Okay. See how it's hard to see because of the glare. See how this dark semicircle is on the side without the plus. There's the plus. Do the other one and then we'll solder them both. You see the tricky bit here, sorry, I just realised it was off camera. The tricky bit is here is you have to get your soldering iron in there. But it's not impossible. Oops. Look at that. It's a bit blobby, but you can tell it's attached. And then the third capacitor is called C3, which is here. I'll do this one with tweezers. Turn it around. Right. Now for the big ones. These ones, easier to fit on the microscope. There you go. Up here. Got really big pads. And they're marked. You see they're marked shaped like the bottom of the capacitor. Don't worry too much about matching it perfectly. You just have to make sure that their pads are soldered. There are little legs that need to be soldered. Same applies to these. You do one pad. And because it's so big, you can just do it by hand. And I might as well just go the other side. C9. Don't worry too much if I'm going a bit fast or it's a bit lost. You can use the instruction manual, it's very detailed. If you combine these two together, the video and the instructions, you should have no problem. Okay. Sorry, that wasn't on camera. Just did that. Right. I need more components. That is the end of the surface mount components. Brilliant. Let's make that a little bit smaller. We don't need so much. Sorry, I'm just trying to shrink the view. No, we don't need so much focus. Microscope. Next we'll put in the diode. Again, I'm putting the black one in here, but I recommend use the clear one. At the end we'll be able to hear the difference. It's much more subtle. It only picks up the infrared from different lights. I just realised I did it without explaining. Let's get another PCB. Just see on the board, this is where the light sensor goes. It looks like this. It looks like an LED. And you see there's a little dot and there's a little line. That means short leg and long leg. Also the square means cathode and the circle means anode, I think. So you see here, that's the short leg and that's the long leg, and the short leg goes in there like this. It's also on the instructions if you want to look in more detail. Also, you can tell because the flat side is on this side. Next we'll do the switches. They look like this. Same applies to these are surface mount. See that under the microscope? It's called S1 and S2. This one's the amount of gain, and this one is just on and off. You can see on, off, high and low. They're the same as each other. So I'm going to solder one pad. I'll use tweezers this time. See that? These only just fit the pad, but because it's all metal, the big blob of solder on there, it's less sensitive. See, it says gain. To the other switch. Did it by hand that time. See, it says power. Trying to look at the screen and solder at the same time. Not the best method. It's quite hard sometimes, it goes out of shot. Right. Now the trimmer. That is here. Well, I say do the battery connectors. It doesn't really matter with this one. Let's do the batteries connectors. They look like this. Now, one is for positive and one is for negative. If you look on the sheet, it says negative is the roundish one. That's this one. So that's negative. Because on the battery it's the opposite. For this, just for ease, I use a chunky tip. That means I can put more heat into it. And zoom in. Just push it down on the surface. Make sure it's a surface that can take a bit of heat, or something that like you don't mind getting a bit scorched. Solder's too thin. Okay. Can move to chunkier solder just because it's faster. Doesn't really matter, but when you have thick solder, it's much easier to do big solder pads like this. And the other one, well, the curly one, is basically positive. Be positive. Go. Be really careful when you're doing this that these are straight. Don't solder them in wonky. The best way to do that is to do one pad first and make sure it's in properly before you finish the others, because it'd be really hard to take them out otherwise. And then the last thing is this, the trimmer. Put it under the... That's marked VR1 on the sheet, and it's marked VR1 on the board. Solve those. Because this is going in a metal tin, it's a good idea to cut them really flat with your cutters, even the battery contacts. Don't launch them across the room like I'm doing. If you want to make them look nice, you can reflow them a bit. Not got enough time for that. Right, so how far are we? Do we have any more components? No. Look at it, it's all done. The only component left is the jack socket. If you look at the jack socket, it's a stereo socket. That is earth, ground, or whatever you call it, and these are left and right. This is where your wire comes in. Remember these wires? I've got different coloured wires, but you don't really need to. You just need to make sure you get them in the right place. So I'm going to use black. Strip off the ends. Tin it by putting a bit of solder on the end. It makes it easy to solder to a pad. And so the marking for the connector is actually on the bottom. So if you look at the PCB, it will have this on the bottom. It's got right, negative and line left. If you look on the PCB, it's there. I'll show you it here. Nope, that's the top side. There we go. So I'll solder it here and you can see it there. First to tin the pad. Now we've actually provided little holes so you could feed the wire up and over, but the wires we're using here are way too chunky for that, so I'm just going to stick it on the top. If you do this, make sure it's quite short. There's left, right, and there's left. Strip those. Tin them. Sorry about the focus. Cut them short to make it easy to solder. Which one's left? Going by the convention that right is red, left is black. It's totally irrelevant really. Wires could be any colour. They could be the same colour if you wanted. strip the other ends. Now, into the jack. So the black one, which was the negative, goes there. And the left and right go here. It doesn't actually matter which way around they go because they're actually the same signal. It just lets you use headphones with it, because otherwise if we only did one pole, you'd only get in your left or your right ear. So I could try doing these on the microscope maybe. It's good to fit them in the tin. You need to fold this one down, because if you imagine the tin surface there, it's much easier like that. And to fit it in, if you bend them slightly this way. There you go. Pre-tin the. Hard to keep this still. Pre-tin that. Earth. Sorry, I'm using earth and ground and negative interchangeably. Get told off for that. And I'm doing it off camera. Sorry. See, I've done these all short like that, with pre-tinned with solder. So we can put the black one, which comes from the negative stripe, the one in the middle. Put it in. Tab it on there. And for the back ones, it really doesn't matter which way around it is. If you want to know, tip is usually left, the ring is normally right. I think that's this. You wouldn't notice any difference if these were the wrong way around. I'm going to have to do it in this camera, sorry. An alternative way to doing this, you could actually hold it in a helping hand, or you could screw it into the box, solder it in place. There we go. And that's the connector done. That's it made. Look at that. Let me hide the microscope. Let me just make it smaller. There it is. Now, we want to put it in the tin. It also comes with 3 rubber pads. The idea is that you put 2 up here, like that. Oops, a bit wonky. That holds the board at the top, but if you look here, you see this. That is where these connectors might touch the tin, and this is actually conducting. So how do we prevent that? Well, when you put the battery in, it should rest about here. It will rest there and keep the whole board up. Like that. And to mount the jack, all you need to do, unscrew that, put it in the tin, be really careful when you're doing this, because if that touches the tin, you might get short. It's not the end of the world with a battery, it'll get warm. Now you can tighten these or finger tighten them by hand. And then that's it, that's done. Let's see. Now for the magic moment. Does it work? Let's hope this battery's got enough power. If you make your wires a bit too flexible, it can get a bit tricky. These are slightly too thick wires. It's okay though. Once it clamps down, it's fine. Okay. Now, to power it, it's that. And I'll show you. It's a good idea. It can be quite deafening, so don't put on a pair of headphones straight away. Put them into the headphones, but don't put them on your head. Especially don't use in-ear headphones. It's very risky, just because it could be quite loud. Turn the volume anti-clockwise, fully to 0. That means no sound can be made. And put this gain switch down, like this. You could use speakers and keep them down to 0, or you could use headphones and just not put them on, just for when you're first testing it, because you could have put something in wrong and made it oscillate crazily or something like that. Okay. Let's try it. I think this battery is dead. Yes. Now turn this up. And it works. It's not as sensitive, this black one. It's much better to use the clear one. Turn gain on max. These are the lights in the room. It's overdriving the studio lights. Oh look, here's the monitor. Something's making a weird white noise. Turn it off, show you. Get it in the tin. Okay. Now you could... Right. Don't use as flexible wire as me. I recommend something a bit thinner than this. The board relies on being clamped down when it's closed, but it's difficult if the wire is really flexible, it kind of pushes it up. There we go. Now you can use it like this. Put the sticker on. One key live version. There we go. Do another test. See, even though it's picking up infrared, it does sort of pick up things. It's much better to build this version, which is identical, except for we use the white. It's one made earlier. The white diode. The clear diode is much better. See, the wire's a bit better here. Just experiment with different thicknesses. There's some strange light making white noise in here. go back to this view. Whoa, that's the screen. Oh, I think it's these video lights. These are. I've walked in the dark and with one of these out the street lights. It makes an amazing harmony of different street lights. It's quite limited in here. Oh look, we can do the soldering iron. Anyway, that's it. If you've got any questions, ask on the Slack. And thanks for watching. I hope you enjoy this project. It's coming out on... We're sending it out next Monday. On Monday the 11th? Oh, I shouldn't have tried to say that. Yeah, Monday the 11th. Should be sending them out. Ask on the group if you've got any questions. Or you're a bit worried about doing surface mount and we can help. Alright, cheers, bye.